This is day 17 of Advent of Cyber 2024, and this challenge is called He Analyzed and Analyzed till his analyzer was sore. So, the backstory: Marta Mayware is going crazy. Someone has disconnected the main server from the Wereville network. Nobody knows who it is. As soon as she realized it, she contacted Wereville's top physical security company, WereSecond Aware, to let her view the data center's CCTV streams. They forbade it entirely. For privacy reasons, only the camera owner can view the recordings. Not even the WereSecond Aware employees themselves allowed to do so. Still, they said there was no recording of anybody entering the data center yesterday. How could that be? Wondered Marta May. Desperate for answers, their first supposition was that the owner of the cameras must have deleted the recordings from their managing webpage, but the data center's camera owner surely can't be the perpetrator. It is no other than Byte, Glitch's dog. Glitch insisted with Marta to leave the ownership of the cameras to Byte precisely to avoid these kinds of happenings. Byte, the ultimate good boy, combines loyalty and sharp instincts to keep any place safe. Marta May calls Glitch and McSkitty right away, explaining the situation in between the sobs. Glitch's eyes darken. Someone is trying to frame Byte, and he will not let anybody vex his beautiful dog. McSkitty is perplexed. Why are the people at WereSecond Aware supposing that Byte had deleted the recordings? Shouldn't they have some logs to prove such an accusation? Marta May has the answer. They do have some log files that they back up every 6 hours, but they can't search through it. Or rather, they tried, but when they go and search for some keywords like the data center's cameras, IDs, or the delete action, this is what they get. And it's just unreadable. McSkitty shakes her head. They must immediately send the log files to the SOC team. Armed with a SIEM, no log is unsearchable. So the learning objectives are to learn how to extract custom fields in Splunk, learn to create a parser for the custom logs, filter and narrow down the search results using the search processing language, and learn how to investigate Splunk. So we will start the virtual machine, and we will have a direct link available to it, which will be here. Okay, so the machine is now up, so we've got the link here, which we will open. So it's time to fire up Splunk, where the data has been pre-ingested for us to investigate the incident. Once the lab is connected, open up the link in the browser and click on Search and Reporting on the left. It is now loaded up, so we go to Search and Reporting on the left right there. So we then, on the next page, type index equals asterisk in the search bar to show all ingested logs. Note that we'll need to select all time as the time frame from the drop down on the right of the search bar. So we do index equals star, we then change this to all time and then search. After running the query, we will be presented with 2 separate datasets pre-ingested to Splunk. We can verify this by clicking on the source type field in the fields list on the left of the page. So we've got source types here. There's web logs and CCTV logs. So let's explore the logs and investigate the attack on our CCTV servers to identify the culprit, who got unauthorized access to the server and deleted the CCTV streams. So examining the logs, we can then change the source type to be CCTV logs and search. So when that loads, we'll have the logs for it. After examining the logs, we can figure out the following main issues. Logs are not parsed properly by Splunk, and Splunk does not consider the actual timeline of the event. Instead, it uses only the ingestion time. So fixing the problem, before analyzing and investigating the logs, we must extract the relevant fields from them and adjust the timestamp. Provided logs were generated from a custom log source, so Splunk could not parse the fields properly. So click on the Extract New Fields option, located below the fields list on the left of the page. So if we go back to here, we've got our logs, and then Extract New Fields. Select Sample Event. We will be presented with event logs that must be parsed properly, though we can select any log. But in order to follow the steps mentioned below and avoid confusion, let's select the very first sample event and click on the green Next button at the top of the page. So if we go to here, should see the raw, which we do. I think it says select any of them, and go Next. So for the selection method, we will do regular expression, and for the fields, we can highlight different parts of it. So we will highlight the whole thing, and we will call this, let's see, what do they call it? So timestamp. Then this is event. This is user ID, and that is username. And lastly, this is session ID. So once we have all these, we then go to Next, and once we've done that, we should see that it's on each of the events. We've got that from the raw data, and that looks to all be correct. So with that validated, we can then go to the next page, and we can go in and finish. So we will then go explore the fields I just created in search, and with those fields created and looking at specifically at these logs, we need to change the time range to all time again. We now have the event, index, and user ID, which you can see here. There was activity by byte, software, glitch, Marta, Maya malware, freeware, and hardware. And if we look at session ID, some of the fields have not been extracted as expected. So we will need to improve the field extraction. So there are some where it's like this, where login successful, 3, Marta, and then this. So we would then need to go at the top here, settings, fields. We'll then need to go back to field extractions, and we need to search for our one, so CCTV, which is this extract, and apparently we now need to delete it. And with that deleted, we then need to go to open field extractor and update the regex. So source type, CCTV logs, and we will select all time, if I can find that, right there. And then we will do, I prefer to write the regular expression myself. So this is the regular expression being used. So we're recording the timestamp, recording the event, user ID, username, and session ID. So let's save that. Actually, we'll go back and then do preview if we can. Get preview. It's not showing any event, so maybe we just need to go straight to save and finish. So explore the fields I just created in search. Increase the range to all time. And if you go session ID, that appears to have fixed that. If we go username, that's still there. Okay, so that seems to all be good now. So investigating the CCTV logs. So we've now sanitized and properly parsed the logs. It's time to examine them and find the culprit. So summary of the CCTV events. We can create a mental picture of the information these logs provide us, and a brief summary of these logs is: these logs contain the successful and failed login attempts from various users. They contain a few failed login attempts, which look suspicious, and they contain information about the CCTV footage being watched and downloaded. So we can copy this search, we'll then go through the logs and create some stats about the number of events by user. And we can do a visualization, and we will make it a pie chart. So you can see that Byte had the most events, next being software, then glitch. We can then do a similar search, but thus stats count by event. And we will, okay, so we can see that most of the events are watch camera. Then there's also log out, login successful. But then there are very few 16 login failed attempts. So now we can also look at rare events. And if we change this visualization to a graph like this, we can see there were 2 delete recording events. So it looks like we have a few attempts to delete the recording and a few failed login attempts. This means we have a clue. So let's now examine the failed login attempts first. So we'll copy this search, which is searching on the index CCTV feed, and it's doing a fuzzy search for failed. Then it creates a table of the time it happened, the username, the event, and then the session ID. So if we switch back to events, should we go visualization, what am I looking for? There we go, statistics. So you can see the time this was happening. The username Byte had failed logins, so did Marta, so did Glitch. So they were trying all failed logins on all the users. As you can see from the timestamps, it all happened at the exact same time, and it all came from the same session. And, well, since they're blacking this out, it's safe to assume that will be a question that we'll need to answer. So let's go to the questions and enter that in. So the session ID associated with the attacker who deleted the recording is this. And we may as well go back to how many logs were captured associated with successful login. So if we go back to here, we'll put this in, and there were successful logins was 642, and that. Then the next one's the name of the attacker. But we will go back to where we were and continue. So narrowing down investigation. So we will grab this. We will go back to the previous search we did, right here, and we will select the session ID. So we're searching the index based on only events that have the session ID within it, and we're creating a table based on that. So we can see Byte was used for deleting records, and we can see there was a bunch of failed login attempts, but then there was a successful one where they watched download recording, watched downloaded, and deleted. And I assume if we, so we've got that. So let's see how many events related to the deletion were captured. So we put that in, only 2 events, although we established that before. So now we need to try correlating it. So we'll go to web logs now and look at that session and try to see which users are associated with it, or client IPs. So we see this IP address, so we know that is of the user. They want us to look at the status. Yep, so this one single status. We'll remove the fuzzy search from it, and well, I guess we can just copy this. So we know the IP, so we're now looking at all weblogs from the IP and looking at the time, status, URI, and path. They misspelt this, so I assume it's URL path, or maybe it's URI path. Okay, we'll change it to URI. There we go. So client, status, URI, URL path, and file. So we can see this IP address was making the request to download, look at the feeds and cameras, and all of that. So we can see logout events when the session ID was changed. We can correlate these session IDs in the CCTV logs. So these are the logs which were the bad ones, and then we had these logs. So we could copy this, although they probably have it. Yep, copy that, go to the top here, and then we should be able to see which user, Maya Malware, was associated with this session. So from the same IP address, they established two sessions. The first one was them trying to brute force into accounts. Then when that was successful, they deleted the logs. They then signed out of that account, creating a new session and signing in with their own account. So we were able to locate the username associated with the attack. Now that we have identified the user, let's summarize our investigation. The timeline of the events: the attacker brute force attempt on various accounts. There was a successful login after the failed attempts. Attacker watched some of the camera streams. Multiple camera streams were downloaded, followed by the deletion of the CCTV footage. The web logs had an IP address associated with the attacker's session ID. We found 2 other session IDs associated with the IP address, and then we correlated back to the CCTV feed logs to find the traces of any evidence revolving around those session IDs, and found the name of the attacker. So if we go back to here, it was M Malware who deleted the logs footage. So that is all the questions answered, and that is day 17 of Advent of Cyber completed. If you like this video, make sure to like and subscribe.